Hello everyone. We will be starting in just a couple of minutes. Hello everyone. Just doing a check before starting. I hope everyone is able to hear me. In case if you are not able to hear me, then just ping me. I hope everyone is able to hear me. We'll be just starting in next 2 minutes. Good afternoon everyone. So we will now be just starting with the session. I welcome you all. And the title for today's webinar is BIM Beyond Clash Detection. This webinar is a part of Wednesday webinar series which is being organized by Neilsoft. This is a part of Neilsoft's initiative of BIM Knowledge Sharing Sessions, which are being planned to be conducted every alternate Wednesdays. And today's session is first of this series. To start with, let me introduce myself. I am Prateek Singhal, the host for today's session. I am an architect and currently working in Neilsoft as a BIM manager. My past experience has been with architecture organizations where I've worked as an architect and BIM manager as well. So today's session is a sort of architecture edition, which we have named it. And the topic we will be revolving around use of Revit for massing studies, some sample case demonstrations, and some specific area-related tools available in Revit. To start with, let me just give a brief introduction about Neilsoft. Neilsoft is a 800 plus organization which was established in 1993, and we are headquartered in Pune. And today we have a pan India presence with offices in Delhi, Ahmedabad, in major cities Bangalore, Chennai, Mumbai. As a company, we are gold partners to Autodesk, and recently also tied up with Trimble, and we are authorized resellers of SketchUp. The SketchUp was earlier part of Google portfolio and now is a part of Trimble. In BIM domain, we are highly active in BIM implementation and other related BIM services. So before beginning the presentation, let us just go through a brief about BIM. BIM is a philosophy, and some say it's technology, it's a concept, it's a philosophy, and it has its application all through the life cycle of an asset, right from the conceptual design stage to detailed design to documentation to fabrication to construction logistics planning to operations and maintenance, facility management, and even to demolition. As for the current market trend and a recent report published by RICS, the most common words which or the most common benefits which user think they can extract out of BIM are coordination advantages, communication, threat detection, and all such things. And we have felt that although BIM has its application into the entire life cycle of an asset, there are certain areas which have been ignored. There are certain areas which are more popular as present in the screen. There are certain areas which have been ignored, and that is where we thought of conducting this session to educate the industry about other less known or less harnessed benefits of BIM. So in this presentation, we will be focusing on BIM benefits which the architects or designers can harness by using BIM-based tools right in the concept design stage, right in the very beginning of the design stages. Today, we can generally see in the Indian context that BIM is being involved in the project at a pretty advanced stage in the design, say just before the GFC or in the later design development stage where 2D to 3D conversion is being done. Although that is also helpful, but then it limits the advantages of BIM which one can harness. Had it been BIM-based tools being used as a replacement of CAD right from early design stages, the benefits which the designers and all the project stakeholders can harness are far beyond that. So in this session, we will be focusing of how BIM-based tools can help in the conceptual design stages. And for today's presentation, we'll be demonstrating by using Revit. Revit is one of the software applications based on BIM technology. So, today's webinar is divided into 3 modules. In module 1, we will see how to use conceptual massing models to determine best mix of building spaces, to calculate rough cost estimates for building facade, building volume data for engineering planning, how can we derive out of just massing models. We will also have a look how easily we can compute certain area requirements which are required in a project, say FAR, ground coverage, or other related things. Similarly, we will also see how these things can be, massing tools can be utilized for complex shipbuildings. Whereas in module 2, we will just take a case, we will present a case demonstration which is of a typical residential project. We will be taking a hypothetical residential project, a group housing project, and see. We will demonstrate a couple of ways in which BIM-based Revit massing tools can be utilized in the concept design stage for a residential project. And at last, in module 3, we will see that after we have advanced through the concept design stage, during the design development stage, there is a lot of requirement that the designers have to keep track of the various area figures. So how area plan tool in Revit can help designers keep track of the area statistics. So we will just start with module 1. I think I have mentioned this earlier. It's a demonstration showing a couple of ways in which Revit's massing tools can help designers during concept design phase. We shall see how the various area statistics are automatically updated as we update or change our mass models. So before starting with the module, I would just like to clarify that this presentation is not a sort of, it's not a tutorial on massing, how to do massing, but our main motto is to demonstrate that how the massing features in Revit can help designers in concept design stage. So let me just start with the presentation. So I'm just opening a file. To start with, I've just created a topo surface, and now I will start making some mass models. In the elevation view, there are currently 3 levels made. I will just change, say, floor to floor height. So I'm just keeping it 3.6 meters. And after this, let me make a couple of more building levels, which I think as a part of my design, they would be required. Now just using the array command and at an offset of 3.6 meters or say 3600 mm, I've just now created project levels. So let me just make it a total of 20 levels. So now I am in my plan view. So this is the message. Now what I did was I am going to start doing the massing thing in Revit, and the moment I select mass to be modeled, it shows that masses were invisible in this particular view. So Revit has by default made them visible. So I say it's perfectly fine. Let me move forward with it. So the moment I select mass, I say I'm creating an in-place mass. That means, as you all would be knowing that in Revit everything is a family. So mass is also a family. So I have two options. Either I can create my mass in a separate family environment, or I can create the masses right in the project environment using in-place mass tools. So the moment I check in-place mass tools, mass related options comes up in the ribbon. So I will just create some basic mass. I will just start with creating a cuboid. I select a plane, it's on level 1. I create my profile, a 2D shape, just adjusting its dimensions. It shows that it's on the plane 1. I go into a 3D view, select this form, and let's say create form. The moment I do it, certain controls becomes available. I can very specifically create the mass models in as per accurate dimensions. So just creating my form of say let's say it's 71 meters of height. Let me just now alter its length and width, x and y dimensions before finishing up the mass. So I'm done with making up the mass model. I will say finish and comes out of the uh, mass editing. And here I see the moment I'm out of the editing interface of mass, and here, although I can not now enter dimensions to it, but I still have some controls available through which I can alter the shape of the mass. Now I am using mass flow tools. The next step which I'm going to demonstrate is that how the area think, how I can calculate flow-wise areas of this mass. So there is a specific tool which is called mass flows, which is to be utilized for this purpose. And I select that this particular mass, let this mass cut at all 20 levels. So depending upon the height of the mass, some mass flows will get created. Now we can see, depending upon its height, at whichever levels this mass had cut the building floor levels, a mass flow corresponding to each level has been created in this mass. I select this mass flow and I see its properties here on the left. These are the properties which have automatically been computed by mass flows based on the outer periphery of the mass. Its flow perimeter, floor area, exterior surface area, flow volume. Similarly, we can see of the other mass floor as well. So moving forward, the next step is to let me process this information in the form of a schedule. So I go to a mass schedule and select mass flow. Schedule properties dialog box opens up where I have the available fields and I can select which fields do I want to be scheduled. So I select a couple of fields. I just reorganize that schedule so that it is more presentable, so that it is displayed in a more meaningful manner. So here what do we see, that there is a single mass in the project, and for this mass at these very levels, this is the floor area depending on the mass profile. Let me add a couple of more parameters. I am adding a usage. That is, what is the usage of each floor plate. Currently, there is no information in it, but we will utilize this parameter as well in a few minutes. So what I just did, I isolated my mass flows, and suppose this is a tower in which it's going to house, say, retail spaces, office spaces, and residential spaces. It's a mixed development project. It's a mixed development building. So say in the first three levels, I specified its usage as retail. I select the first three levels and in the properties dialog box, I entered its usage as retail. Now I will select other six levels and say that I'm planning it to be offices. As a design, I'm planning it to be offices. And say the next levels will be of residential use. So the moment I have entered this information into the mass floors and I check back what does my schedule says now, I can see that this information has been uh, displayed in the schedule. And the beauty lies in that how I can process this information now. Within a few clicks, I can easily compute what's the total floor area for my retail, for my offices, for my residential. So see, so now if I ever feel that no, I feel that retail is too much or say residential is too much, I can do my modification here itself. I can do that in the mass itself, but in that way, the beauty is that every information which you need to give it only once. So suppose I feel that there have been no parking. So let me say dedicate say the ground floor to parking. The moment I do that on the level 1 mass flow, parking has been filled in. And consequently, I just change other such spaces, keeping a total number of 3 floor spaces dedicated to retail. So, well, this is not, this is just the beginning, I would say. Suppose now you are in the process of developing your design and you feel that let me just develop the design more further, do some further design developments. So I'm creating a form and say I decided this, say at the cornermost portion there would be a void. I select it, I select a void form. And the moment I say finish and come out of the sketch edit mode from mask, I see my mask flows getting aligned with the profile of the mask. And this doesn't end there. The information is well transferred into the schedule as well. I can see for a couple of levels, say from 7, 8, 9, 10, which were earlier 525 square meter of floor area, that has been reduced to 405 square meter. And consequently, the space available for office and residential area has been updated. So very quickly you can process this information if you're using Revit at concept design level. Now what I'm doing is I'm just making a couple of more mask floor schedules because I wish to display some other areas. I need to analyze some other area values. So I've just created a different schedule and I just rename it. So on the left hand side, we see there are two schedules now, mass flow schedule 01 and mass flow schedule 02. So let us see in what ways we can display this information. So as I mentioned earlier, floor area was one of the parameter which was available to us, and there are other parameters also available, say flow parameter, exterior surface area. And this parameter is available floor wise. So when I talk about exterior surface area, so if you remember in the starting, I specified a floor to floor height of 3.6 meters. So 3.6 multiplied by floor perimeter gives 360 square meter. That is the level wise surface area. So see, I am just in the design stage, conceptual design stage, and what values I am extracting out of Revit. I am getting the facade area for each floor. And now I can add some thumb rule parameters, some cost parameters to it. Say for these many floors, I'm going to give external glazing. For these, it would be brick and windows or some other material. So you can, at conceptual level, you can also compute your cost. Similarly, there are other parameters. There is a volume parameter which can be added. So, but then at the same time, let's see that how this information is very dynamic. Suppose I change a floor to floor height of one floor to say 3.2 meters and consequently level 3 gets 4 meters, and let's see how does it impact my facade surfaces in the schedule. When I look at my schedule, I see that the exterior surface area has been automatically updated. So the idea here is you need to focus more on the design and let the technology take care of these computational things. So now we will just enter in the second phase of this module and see that how these mass flows get adapted to complex shape building. So I am in the edit mode of a mass and I just twist it. Just before moving forward, I will just like to specify that if there are any questions in between, if there are any questions or queries, you can just ping me, drop me a message, and they all will be addressed at the end of this webinar. So let's see that how mass flows adapt to complex shape forms like this, where none of the flow plate is similar to the other. And we can see that all this information is available to us within a matter of clicks. So again, I repeat one more point. This tool helps you focus more on the design part of your buildings rather than on the calculation or laborious jobs. Say I just name this building, say building 01, and let me introduce a couple of more buildings in this project. Suppose in this project I have planned that there may be multiple building blocks. So I have now just introduced another building block, and again using the mass flow tools, I have specified it to be cut at all the levels. So depending upon its size, it will be cut only at say 6 levels. So I select the mass and again specify it at B02. Now let us see. So the schedule gets displays all the information, but then let me just process it in a way so that it provides a more meaningful output, a more say readable or more comprehensible output. So I'm just sorting it out, say by mass commands. I'm sorting them by levels, doing some formatting, display the totals. Okay, fine. So I have just a minute. So the moment I do that, totals, okay. See, now my schedule has been segregated mass wise. For mass 1, this is the total area. For mass 2, this is the total area. So just processing it further, for building 01, this is the distribution. I have not specified the usage for building 02 on each floor, what would be the usage. So I'm just specifying it right now. Say this is building 02 is the complete retail block. Oh, sorry, mix of retail and offices. Again. And then if I click on mass flow schedule 2 and see, just a minute. If I click on mass flow schedule 2 and see, now there are two building blocks. Now I can compute that how much each area has been allocated to the total, how much office space do I have in two blocks, how much residential space, how much retail space do I have in these two blocks. Those area figures, those floor area are readily available to me, and I can just keep on working the design and these figures will get updated. So I will be showing a couple of more ways in which we can say utilize these tools. So I've just created another schedule. Say I just wish to compute, say the ground coverage, the footprint of these building blocks. I just do some sorting and say I just filter by plinth level. That what's the footprint on level 1, and just doing some organizing and sorting. So this gives me that here's a footprint at the level 1 of each two buildings. So I now enter a calculated value parameter which will help me compute the ground coverage right in percentage terms. So let me just enter the formula floor area. So this I have calculated the site area. It's 5,000 square meter. The moment I add this, I get the ground coverage, but I need to do some formatting. So I just check the field format. No, it's a percentage. I also want a symbol and to two decimal places. Now that's done. I click OK and just see that what's the footprint of my two building blocks. It's 6% and 15%. I also set this calculate totals. Now see, now if I have done these setups and now I can just focus working on a design, and every time I just don't need to recalculate my ground coverage or FAR thing. It will be just readily available to me. Few clicks. Now one can always argue, say the ground coverage is always at the topmost limit in building 02 is uh, tapering, projecting outwards. But then what we intend to show is the possibility. I filtered it out for level 1. You can filter it out for the topmost level in the ground coverage schedule for the ground coverage. So suppose I decide that the footprint is less, the floor area is less. Let me just update, modify the building, and let's see how this impacts on the ground coverage. I click on my schedule. Now it's from 21% is now 28%. I can have a look at the total floor area. With me it is 30,400 square meter. So I'm just moving out of the schedules now. So this was the end of demonstration for module 1, and we can see what do we have in summary. Mass flows once created adapts to any further change in the respective mass object. During the conceptual design stage, at any instant, these values are available to you. Floor area, exterior surface area, perimeter, volume, etc. You can organize your project with the help of schedules to keep track of ground coverage, total floor area of the project, and other such things, and keep working on your design. Designers' time will better utilized by focusing on the design and no need to recalculate areas again and again. And now this is one very important tool. Very quickly one can compare the area statistics of multiple design options. So on the right hand side you can see that there are two design options. So let me just uh, make it larger. So there is option 1. In their 3 blocks I have 33% of ground coverage with 14,374 square meter of total floor area. So in a separate file or even in the same file using another important tool of Revit, say design options, I can create, modify my form and see I've changed the building form, reduce with the objective of reducing the ground coverage. So it's 25% now, but keeping the area figures in much it's the same as the earlier one. It's 14232 square meter. Earlier was 14374 square meter. So these just things you can do very easily and very efficiently using Revit in say concept design stage. So moving forward, now we will be starting with module 2, which it will be is a sample case demonstration on a group housing project. Uh, for this demonstration, I have considered a hypothetical group housing project which comprises of say 2 BHK units or 3 BHK units, and there are multiple towers in that project. So we will see how to utilize Revit massing and area computation tools for such kind of project. The intention here is to show that how we can utilize these things. There would be many other ways the users can work with these tools in the many more innovative and creative ways. So we will see how we can dynamically or keep track of number of units, tower-wise floor area, ground coverage, and even also with a few using the calculator and other such stuff, we can very quickly, based on the figures presented in a schedule, compute the design efficiency. So we will just start with the demonstration for module 2. So I have created a site for this project, a topo surface, and I say that in this, from design perspective, there will be maximum of 17 number of floors, each at a floor height of 3.15 meters. So I have created some mass objects in it. So I will just switch on the mass and I will say a tower block I have prepared. Now please note that earlier I had used in place mass families, but here I have modeled these masses in a family environment and brought them here. So before moving forward, let me explain the color coding. The blue color resembles a 2 BHK tower and light blue color is its balcony. Similarly, green color resembles a 3 BHK unit and light green color its respective balconies, and the yellow color represents a core. Now, before beginning moving forward, I would like to specify that there is no hard and fast rules of doing such things. I created a separate block for the balconies because I needed to compute its area separately. My objective is in this massing exercise to compute the area of balconies separately and later update the balconies and calculate the ratios from the flat area to balcony area and all such things. So now let me just show that I click mass and go into edit family. And the moment I do that, we are going into the family environment. And here we can see that I have created a family, added some parameters which I know will be utilized in the project like floor to floor height, mass height, plinth level parameter has been added. I have also added a parameter, say number of floors. So in my project environment, I just need to type number of floors and my building height will automatically be adjusted. Just showing you an example that this can be one of the ways in which you can use Revit as well also. So I will just go out of it and come back into my project environment. And now I will go forward with doing the area calculations now. I can change the number 13 to any and the height will automatically be adjusted. And there is one other shared parameter which I have added is associated tower, which we'll be utilizing in say a couple of minutes from now. So what I do now, I just select my mass, go into filter option and see oh there are only masses have been selected. I select mass floors and specify from 10th level to 17th floor level, depending upon your height, make mass floors at each level. So the moment I do that, mass flows have been created. And much like the same way in the earlier model, I just now need to process this information in by extracting schedules. And let me just extract one schedule. Now, if you remember in the last demo module, I had made schedules of mass flow. But let me now just make simple mass schedules and let's see what information is available different to us in this case now. So there are these parameters available to me. But let me see which would be useful for me. Say I say need family, I need type. Gross floor area would be useful definitely. Say gross floor area, I need count, I need associated tower. Any other number of floors. I think it's done. Fine. Say type commands now. Let's see. Now again, it's just a tabular form. I reprocess it. Just doing some sorting and such things. Now I have this figure in front of me. So I have balcony units, I have core, I have flat. I can see that each of the block is say 13 floor high and this is the total floor area which I'm getting of my say balconies for flats, for core, for this building. And now let me enter some more information into these masses. Suppose I select all the masses. I just go to filter tab and show uncheck mass flows and I enter utilize this associate tower parameter. Say I enter tower 1. The moment I do that, go into my schedule and can see that this information has been reflected in the mass. So I can say if I uh, don't want to have a look at the balcony, I can filter it out. I can compare these areas. I can with a few clicks in a calculator, I can compute the efficiencies that the total tower area is this much, the flat area is coming this much. So now I would like to just mention one more thing before moving forward. That the masses which I have made, I have done a mock. I've done my planning and say I've designed a 2D 2 BHK unit or say 3 BHK unit and a core and 8 to a core thing and then made my mass models. You can even do it other way around. You can decide for a footprint of your building units in a mass and work out with the schedules in the best possible way to harness the efficiency to get the efficiency and then see check that are you able to design within that space or not. So let me do one thing. Let me introduce a couple of more tower blocks in it in the project, which may not be 13 story high simply. They may be of different heights. And let me see how my schedule processes that information, displays that information. So I have tower, just under tower. Let me create another tower now. This tower 3. So again, let me enter the value in the mass is in the associated tower. I should name it as tower 02. These blocks belongs to tower 2. And similarly, on the third tower, let me enter this value in the associated tower parameter. Now, please note that these parameters you don't get when you by default. These are custom-made parameters, and you can enter any number of parameters you want. So I've just processed the information. Now I have a tower-wise schedule of course, area, and flat area. I've just filtered out the balcony area. Now I can analyze this information. And now I can work on the design on a mix of what height each tower should be having. I can work on the design, and this schedule will take care of my units and other such things, my floor area and other such things. So now let me just have say flat. Now I can just talk about the total flat area available in this project. You can utilize it in any number of ways. In any number of ways, you can process this information. Just doing some formatting now. Okay, fine. So now let us change the heights of tower now. Say these blocks are fine along with balconies. Say I decided that they from 13 story, let they be 11 story high. And these are 3 BHK units. I decide them to be 11 story high. I filter out the mass flows and say 11 story. Let me see. Fine, fine, fine. So say tower 3, I think it, let me say it's a bit more higher. Say 17 story high maybe. Yeah, right. So, so let's see what's the immediate impact on the schedule. With just a click, you can see your impact. You can see that a couple of 3 BHK units in tower 2 are 11 story high, and they have this 1 to 5 per square meter on per floor per unit area. So no, so the total tower area. Now let me extract a couple of more schedules. I have this much information in the project, and let me see in what many ways I can process this information. I now extract a mass flow schedule. Just enter something and I just say finish my mass flow schedule. And I have now flow wise area. Say say 16 flow on the entire project, the total balcony area for 2 BHK type units is 57 square meter in the entire project. Say for in the entire project in the flat on the 16th floor, it's 314 per square meter. Or in the 10th floor, it's 944 square meter. So let me move forward, and so now let me make a couple of more schedules. I say for what will I be utilizing it? Say, I would say now this schedule I will be using for say number of units. I will duplicate this view, extract a couple of more schedules, and maybe I will be utilizing it say for say let me say ground coverage. So I just name it 02. It's my master flow schedule, and say ground coverage. Now I process this information again much the similar way I had done in module 1, adding calculated value parameters for ground coverage, just doing some formatting stuff, setting up the units, and now I have reached 7.65% ground coverage as of now. So I can keep working on the design now. I have just done my settings for the project, and these will be automatically computed. I go into site, let me introduce a couple of more building levels. So a couple of more tower blocks. So now let me have total of six tower blocks, each of different height, and I can see that now I can extract my tower wise schedule of just say core and flat area. How much do I have in each tower? And I filtered out the balcony area. You can process it in n number of ways you want, and this is just one other way. So suppose now there are then again very intuitive questions you can ask the technology. Suppose you are working on a design, you just thought appear to you, how many number of 2 BHK, 3 BHK units will I have to compromise in case I introduce stilt floor parking in the project? So what you have to do is just go into a schedule, filter it out for the plinth level, and see how many units do you have. So this displays me you have 24 numbers of 2 BHK units on ground floor and 24 numbers of 3 BHK units. So that means if I am going to introduce still parking on my ground floor, I will have to compromise 48 number of flats. So just one example in which you can question the technology, question the tool, and it will give you the output. So moving forward, okay. Let me check pause. Okay, let me just move forward. Now, there are other simple tools which are available in this project. Say shadow analysis, you can do simultaneously at this stage. You can have the sun path diagram, sun position figured out. I mean, you just need to specify the latitude and longitudes of the site with the Revit environment. And from any point of the day, at any day of the year, you can select and you will get the sun position. You can do your shadow analysis. Does all the units are getting the light or not? What will be the impact of one building over the other? All such things for any time of the year. And this is just readily available in Revit. Well, in the coming webinars, we'll be specifically talking about energy analysis. So I leave that for subsequent webinars. But this was just to give you a glimpse that these tools are also available very readily, which can be utilized in concept design phase. So let me see, process this information again. I have tower wise area of say flat and balcony. Now let me process this once again. Let me calculate my design efficiency here. So suppose I'm just calculating it for tower 1, and I can see that I have the total balcony area, total core area, total flat area. Now let me compare the design efficiency in terms of what's the percentage of flat area over the total tower area. So I just need to check on my calculator and type say 10,652 divided by 13976. The value is listed here. So this is the flat area, 10,650 to 13,970 is the total floor area of the tower. I get that's 76%. So 24% of my floor area for tower 1 has gone into balcony and co. So this is a very simple module which I have created. You can create complex shape forms in Revit even in a residential project if you want, and also some minor modifications and design. But you can get all these information available in schedule very easily within a matter of clicks. So this is how we have ended module 2, and just go through a brief summary of module 2, what we have seen. So depending upon the project type and the objectives, users are free to add as many parameters they want in a Revit. And this is a great flexibility which Revit provides. So here our objective was to give you an idea that, see, this is kind of stuff you can do, and this is the very basic kind of stuff which we have just demonstrated. If you are if you are using Revit, if you are you can process this information in a much more meaningful way, and you can utilize it for hospital projects, housing projects, education projects, any number of projects. You can add any number of parameters depending on what output you want to extract out of Revit. So here we end module 2, and now we will be just covering module 3. This is the shortest module. So there is one feature in Revit which is called area plans, and now we will be moving out of the concept environment, concept design stage, and see that there are a lot of challenges in the design development stage as well. This is more relevant in the drawing design development stage. We can track and manage area statistics all along with the design stages. So you are developing your design, you simultaneously need to ensure that I should be able to utilize the floor area available to me to the maximum limit. I should not exceed the floor area. I mean, there should be efficiencies in the user sellable area to non-sellable area to circulation area to the usable spaces and all such things. Area plans can also help you holistically review the design, that how's the area distribution on each floor, and then comprehend the design as a whole and take well good decisions in a holistic basis. So you can efficiently and quickly study the impact of design changes on area statistics. So let me just start this video, this last module. So I think this is the shortest one, so just of 11 minutes. So for this purpose, I'm in Autodesk Revit, and I've just created a building, let's say a hypothetical building just for demonstration purpose, which is G plus 4-story high. And there are a couple of floor plans which I have created. So say these are ground floor plan, first floor plan. I click on the section box. Let me see what's the distribution. So the idea for demonstrating area plans, I will be computing in the first instance the floor area FAR. And I have the building has been designed just that say this is functional space 1, functional space 2, functional space 3, functional space 4. These are the FAR spaces. Waiting lobby, say I'm considering it as a non-FAR area. And the similar design is on each floor. Then there's a lift lobby and other such things. So now I just go into 3D view, have a look at the building in 3D. So there are these functional space 1, 2, 3, and 4 in each space. On the central is a waiting area, which I am terming it as for the time being a non-FAR spaces for the purpose of demonstration. So I just uncheck the section box tool, and the entire building is now visible. So in the project browser, you can see there is no category of area plans. Now area plan is just one specific tool in Revit, and for that, before calculating the area, I need to specify area scheme category. So these two categories are available to me by default. I say I won't be utilizing that, I will be creating my own. So I just name an area scheme category FAR, under which I will compute the FAR area, floor area of the entire building. So the moment I do so, I have just specified the area scheme, and I go into View tab and create panel and plan views. I create area plan. So I am going to create area plan for my area scheme, FAR, area scheme, and say I select, I want to create area plan for ground floor level. The moment I click OK, there are other levels as well. I click OK. It says automatically create area boundary lines associated with all external walls. So I say no, you don't create it automatically. I will be creating manually because I have to specify which are the FAR spaces, which are the non-FAR spaces. So I say no to this warning message. And the moment I do so, on the project browser, we can see that area plans FAR category has shown up. I open it and there is a ground floor level area plan. Now, I now say I want to create a area plan for first floor level as well. Now, please note that here in this, you don't find that any ground floor level mentioned. Reason being, this particular option has been checked, which says that for those levels for which you have created an area plan, don't show that level. Fine, that's pretty cool. So I select, I want to create an area plan view for first floor level as well. It has been created. Now, the next step, first step, uh, creating area scheme. Next, second step, creating area plan. Now, I will be specifying area. I will be creating area boundaries in this plan. So I start creating my area boundaries. Say one. For computing the area boundary should be in a closed loop. So I've just ensured that area boundaries have been created. All other elements have been hidden. Now I switch it on and area boundaries have been created and I specify the area and say it to be, say, ground floor area. Ground floor area. Fine. So I've specified it and I can visually present it. It's just do some shading sort of thing, color scheme. I can say for FAR area, color scheme type you say. Now, this entire I have seen, say it's FAR area. Now I will just extract out those spaces which are non-FAR. So I again select. Now I brought the coloring in foreground, that is over and above the walls as well. Earlier it was behind the walls. So I create area boundaries. I just say I just take this out of the FAR area. I just take out the waiting area out of the FAR area. Suppose I'm considering this for the purpose of demonstration that this is a non-FAR area. Oh, some thing wrong has been happened. Some wrong has happened. Now let me correct it. Yeah, right. Move to area. So the green portion shows the FAR area. I will just reduce the scale. Say this 1:200. I'm not. I will correct the area boundary lines a little while later. But let me just show you the process first. So although this is not going to be the FAR area, but still I say I want to compute the total non-FAR area dedicated for waiting areas. So for that purpose, I have entered this area here. Now I go into sheet. I just click a new sheet and let me compose this on my sheet now. This is a preloaded sheet, a preloaded format, which we in Revit we name as title block. We call it as title block. So it's sheet number, sheet name. I just enter here and FAR area sheet. So now the step which we will be doing now is just to make this entire process more comprehensible. So I just put my sheet here and it's taking too much space on the A1 size sheet. I don't need that much space this plan to take because it just needs a diagrammatic visual representation of FAR and non-FAR area. So let me reduce it down just crop the views. Cropping the views. Mm, Once done, yeah, I don't want the crop line to be visible. I will say uh, before I will uncheck it, deactivate view, reposition it, resize it. Yeah, that's done. And much in the similar fashion, I compose all other sheets. I just do a bit of detailing in the ground floor area plan, and we can see now we have area plans for each floor level. And here, for the purpose of understanding, we have highlighted the functional space tag description as well. So now I go to my sheet view and see what all uh, information I have on my sheet. Now I have deducted the lift shafts from the FAR area. I go into sheet. Now, now this is one beautiful way of working. You have all your area plan figures composed on a single sheet, and any time of the project you can keep working on the design. The design thing will get updated in these plan views, and you just need to see uh, to ensure that your area lines are correct. So I will just do one more step. Last step in completing this sheet is to create an area schedule. And I have created an area schedule and has listed area schedule for FAR area scheme. And the waiting areas are say non-FAR areas. I just put in this information within the schedule. Non-FAR, this one is also non-FAR, fine. And I will filter out the non-FAR area, just keeping the FAR areas with me. Okay. And now after I'm done, I will just place the schedule on my sheet. And once I have done this setup, I can now keep working on my design. And very efficiently, I can locate where are the errors. Am I lagging behind my floor areas? Is it design still not efficient, or I am exceeding the area limits? Now, I will just demonstrate what happens when you do some design change happen. You decide, suppose that this waiting area, the size of this waiting area will be increased. This will be, say, to left, and just completing by adding some walls. We are done. The waiting area size has increased, and now let me just go to my area sheet. And what do I see now? In the ground floor, I see that the design has been changed, and I can quickly I see that I need to update my non-FAR area lines. So the moment I do that, so I just have to I don't have to copy the designs as they changes in plans. I don't need to copy them, but I just can go into this view, area plan view, update my area boundaries, and I see that waiting area has been increased. Hello. Okay, okay, just a minute. Let me. I think कितने देर पहले से? Okay, okay. But I think I was my voice got lost Just let me just rerun for a few seconds what I spoke. Okay. Okay, fine. So let me just rerun my video. I'm just about to complete it. Just a few seconds more. Now, suppose this particular sheet you have prepared for your building, in which each of your area plan has been listed, and you have composed this area thing, and it is very visual. It's color coded. Now, you have done your updations in your design, and you can easily find out that where my schedule has not been updated, where my area boundaries have not been updated. Also, suppose you have done all set. Now you can discuss just on the design on this area sheet itself. Suppose you have to take some decisions. You are exceeding the FAR limit, and you need to see at what all floor levels can I reduce the area. You can just have a discussion on this sheet. This one single sheet can be very helpful during the design stage. So let me just cover the few last slides. So see, during the design development process, there are numerous design stations takes place where the designer just want to ensure that he or she has done best utilization of allowed area limits, or just to ensure that the design is within the area limits. And here, by using Revit, this process is much more efficient and faster. Any design change you make is immediately reflected in the area sheet. The area schedule is automatically updated. You just need to update the area boundaries. And the beauty is that you can also lock the boundary lines with certain elements in the design. So although you have to manually update the boundary lines in the demonstration which I just showed, you can also, for some cases, you can automate that process as well by say associating the boundary lines and locking it by the edges of the floor plate. So if your floor plate increases, your area schedule can be updated automatically, but that's not a foolproof process. So I generally, for personal my use, I generally prefer to do it on a manual basis. So, and many mistakes and errors in area calculations can be easily identified. In 2D workflow, it has been my experience that many a times there are a lot of surprises comes at the end. The designers have been working on the design, and then later at the design stage, they come to know, oh, boss, we have exceeded the area. But in such cases, you can address such situations right at the initial level as well. You can very holistically view the area distributions on each floor plate. And this was just for FAR area. You can create such schedules, such area plans, such sheets for built up area, floor wise, a sellable area versus non sellable area, circulation area versus utilizable area. So all such things you can do very efficiently. So we encourage the use of BIM tools and methodologies at conceptual design stages, which will help us in building a very efficient workflows and avoid duplication of efforts in migration from 2D to 3D at mature design stages. Fine, that's the way of working currently more prevalent in the industry because Revit is yet to make a significant, has not yet entered in the earlier design stages. And that was a motto in this presentation to give you some idea that it can be utilized as it has potential and significant potential to be utilized uh, in the earlier design stages. So this is a recent BIM booklet we have published. It's our conversations about BIM from various industry stakeholders which we have worked with. They have shared their experiences, and we have documented this in a booklet, which the e-version you can log into a website www.nes.neilsoft.com. You can get it from there. So now I will be taking up questions and answers. And just a note that there is an upcoming webinar on 29 July as part of Wednesday webinar series, Enhancing Collaboration Using Vault. It's a data management tool, and we will see what all things can be done in this webinar using Vault. So let me just have a look at the questions if there are any. So you can write to me if there are any questions. Any queries from anyone? I'm still waiting for some. So now just this was one query. Can we get measurement sheet from Revit? So I would just like to, what sort of exactly measurement sheet you intend to extract from Revit? LBH. No, no. Actually, if you talk about say wall quantities and all such things, that doesn't Revit doesn't provide that. It just gives out the total volume. It computes it internally. And this was one other message. What's the difference between Dynamo and the mass model tool within Revit? Now, Dynamo is where you can add computational logic. You can add programming into Revit. So you can you build your form based on certain programs or certain algorithms. So that is again a very powerful tool to be used in Revit, Dynamo. But we can definitely take it up in some other sessions, Dynamo. So I think uh, I'm done with this webinar. I thank you all for attending it. And you can always reach me at on my email ID in case you have any uh, other query. So my email ID is prateek.singhal@neilsoft.com. So once again, thank you all for attending this seminar. Hope this was a nice session for you all, worthy session for you all in terms of knowledge sharing. Fine. Thank you all.